So if I haven't made it really clear as to how this unit goes, our big unit's on functions. Daniel? Okay, our big unit's on functions. The kids in Dash 2, they only cover quadratics. So I put this unit together in a way so that at the very least we could cover the combined stuff at the beginning, but you guys get to go beyond and do extra stuff. Yay! Nobody's overly excited here. Okay. So here's the deal. Today I'm going to teach you guys an algebraic technique that Dash 1s have to be able to do in order to find a vertex. This is probably one of the most challenging topics we have, actually. Just, sorry, fair warning. On Friday, I'm going to teach you guys about a new type of function called an absolute value function. And for those of you who have gotten far enough into your assignment, an absolute value function is one that we'll get to. It looks like this. It would have like a big line and then say x plus 2 with a line next to it. That's known as an absolute value function. Okay, so we're going to do that Friday. Monday, I'm also going to teach you guys about how to do a reciprocal function, which basically looks like this. It would be x plus 2, and then you'd go to the power of minus 1. Okay. And another way of writing this would be to write it as 1 over x plus 2. So this we'll do on Friday, this we'll do on Monday, and then however it's going to work together, the only other function you guys have to do is inequality functions. Okay. Eventually, everything else on this list here, you will learn if you stay in Dash 1 math. So the kids in Dash 1, they've spent a lot of the beginning of their years now, like they're currently working on exponents and logarithms. Their first unit was on polynomials, including cubics and quartics, and then eventually they're going to get to these ones here. So long story short, over the next year of your math careers, that's the right word, you guys will eventually cover all of these. So, okay, here's some more pictures of graphs, just as kind of like my intro. You guys should at this point here know how to do linears and quadratics. We're going to learn new graphs basically over time. Some of them are pretty cool actually. Like the sine function is kind of like a wave. There's huge overlaps with this in physics. Tangent's a very unique one. You'll notice that it's kind of got this pattern where it just goes straight up, then starts at the bottom here. Eventually, we'll talk about what's called an asymptote, which has been a characteristic that I've asked you about, but we haven't covered those yet. Eventually, something like this will have an asymptote. So, anyways, let's get to our point today. Today's goal. We like vertexes because a vertex can tell us so much information about a graph. Okay. For example, let's say that I told you that this equation here was y equals 2 x minus 1 squared. Let's make that minus 2. Let's say I gave you that equation there. I don't even need to graph it. You guys should be able to pick out almost every single property just by looking at this equation. Cassie, can you close that door for me? Okay, for example, what does the value of this 2, the leading coefficient, what does it help you know about? Well, read the little slide I have right here. The leading coefficient determines the direction. Because it's positive 2, what does it mean about your quadratic? Yeah, it's a smiley face one, right? If this value right here was negative, it means it would be upside down. Does that make sense? It also kind of tells you the shape of the function. The bigger this number, the steeper the graph. So just by looking at the equation, this value right here tells me whether it's upside down or right side up. Collectively, this value and this value right here tell me where my vertex is. So if I get an x minus 1 and a minus 2, the way it works is if this is minus, then it's actually like a positive number. But then the second one, treat it as it is. So since the second number is negative 2, there's my vertex. Well, now I should know the range of my graph. The range of this graph, because this is a positive number, means it's going upwards. And since this right here is the lowest it gets to, I can tell you the range is y is greater than or equal to minus 2. Because of this, I can then tell you whether or not this thing can be solved. Let's say I ask you to take this graph right here, and I ask you to tell me where it's equal to 7. Is that solvable? If I ask you to tell me where the graph is equal to 7, is it possible for us to solve that? I'm not asking you to solve it, I'm just saying, is there an answer? Some of you are tentatively nodding. Because where is 7? 7 would be like up here. Does this graph cross at 7? Yeah, over here and over here. I could use the quadratic formula if I really wanted to. I could try to solve it. But hopefully you'd agree that there's going to be an answer. 2 answers. What if I asked you where f of x was equal to minus 3? Is there going to be answers? No. How do I know this? Well, this minus 2 right here pretty much gives it away, because the lowest the graph ever gets to is minus 2. And so if I want to find where it equals minus 3, I can't. And I'd like to show you that on paper. Let's take the equation I just wrote out here. 2 bracket x minus 1 squared minus 2. And I'm going to try to make it equal to negative 3. I'm going to try and solve for x. Let me just walk you through the basic steps as to how I know this won't have an answer. Because I know this minus 2 right here is not big enough, is not low enough, I guess, to allow me to get an answer as a minus 3. But let me prove it. To get x by itself, I would add 1 to both sides. Sorry, add 2 to both sides. If I add 2 to both sides, this bit goes away. And I'm left with 2x minus 1 squared equals minus 1. Then to get x by itself, maybe I would divide by 2 on both sides. So then I'd have x minus 1 squared, and it would equal negative 1/2. How do you get rid of a squared sign? How do you undo this squared sign right here? But we just did this unit. If you guys can see, I'm doing these units very purposefully. What happens when you try to square root negative 1/2? You can't! That makes sense? Try to square root a negative number. You can't. At this point right here, we've now reached a mathematical contradiction. You cannot square root a negative number, which now is another way of explaining why this graph right here, if I try to throw on a line here at negative 3, and I ask you where will it equal negative 3, the answer is you can't. You also could use the quadratic formula, by the way. If I wanted to, I could expand this thing out, try the quadratic formula, but I can already see that isn't going to work. So, long story short, my goal today is to try to help you guys be able to get equations into vertex form, because vertex form is so useful for figuring out whether or not a solution can be solved. Does that make sense? So, what I'm going to do right here is kind of more or less the same task that I just showed you, only rather than this being in vertex form, this is now in standard form. You guys remember standard form is how you kind of write it with like your squareds, then your ones, then your constants. So if I were to ask you where this equals 3, here's how another way we could go about doing it. I could say negative 2x squared minus 5x plus 3. Let's let it equal 3. Now, if it's written in this format, now how do I figure out whether or not it can be solved? Well, I would say make it equal to 0. Make it minus 2x squared minus 5x equals 0. Then this sort of thing here, either factor it or use the quadratic formula. You can actually factor them. What's in common here? X. Factor out x. It'll leave you with negative 2x minus 5, which means that one of your roots is 0. The other one, let's see, so make it equal to 0. I'd add 5 to both sides. There's my other answer. Negative 5 over 2. You guys able to follow that? Let's check our work. While you're kind of following that, don't worry about typing this in your calculator, but I'm just going to get it set up for this. Let's confirm I did it right. I'm going to type in a graph of negative 2x squared minus 5x plus 3. And then I'm going to type in a second graph at 3. Then I'm going to put it on a nice graph here. Okay, there's my graph. Here's where it is at 3. I'm going to intersect. Yeah, okay, that one was at 0. The other one over here, negative 5 over 2, what's that going to be? Negative 2.5? Let's try it. Intersect over here. Negative 2.5. So now I've shown you two ways of solving. One is using a graphing calculator. Another one is doing it algebraically. But I hope you'd agree here that that actually is a little bit long to solve for, because when I ask you to solve this one here where it equals 8, now that we've graphed it, can you guys clearly see that this graph is probably not getting high enough to reach 8? But the only way I would know that is either by graphing it and discovering it, or by trying to solve it using the quadratic formula. But didn't you guys hate in the first unit using the quadratic formula and then discovering that it didn't work? And then you'd go, oh, this is dumb. Right? Wouldn't it be nice if there was a faster way where if I could just look at the equation, I could tell you right then and there, no, this is not going to work. Right? And really, if I go back to this slide right here, it comes down to this. If this number right here is minus 2, and I ask you to find minus 3, then it won't work, right? So the whole point of my lesson today is we would like to have things written in vertex form because it's super useful to just look at it and know. Okay? Not that we don't have skills to solve, but this is a little bit faster. So I'm going to move on here. That's kind of the point I have on this slide here. Obviously, the vertex is a very crucial point. Depending on where it lies, tells us whether we have one answer, two answers, or there is no answer. Okay. And the next thing I write out here is, look, you guys should be able to find the vertex using min or maximum on your function, but because you guys are in dash 1, an expectation is you should be able to also do this algebraically. So now that I've given you a really long preamble to our lesson, do you guys feel like you get what my goal for the day is? The goal for the day is I need you to be able to write things in vertex form. So here's kind of my goal then. There are 3 different ways we can write an equation. We could write it in a factored format. Like, for example, it could be 2 bracket x minus 1, x plus 2. Let's say that a quadratic is written in a factored form. Why would that be useful? What does it tell you just by looking at it, Kevin? Yeah, it tells you your x-intercepts. What are my x-intercepts? 1 and negative 2. So if something is factored, that's a great way to tell you x-intercepts. What about in standard form? What if I gave you 3x squared plus 5x minus 7? What does standard form tell you just by looking at it right off the bat? There's actually one thing. What'd you say? Say that? Yeah, although they're all going to be degree of 2, so that doesn't necessarily narrow it down. That'll work too. I was going to focus on this guy right here. The minus 7 tells you the y-intercept. But again, I feel like I've been so redundant today. My goal today, vertex form, tells you where the vertex is. Vertex. So each of these formats has something they can tell you that's useful. But our goal is to get to this one right here. So let's do some algebra. Before I get into vertex form, though, I'd like to just practice some algebra skills again, because it's been a while since that unit. Let's talk about how to rearrange between different formats. This is actually, for right now, it's a review of like grade 9 and 10. What format is this currently in? Vertex form. Where's the vertex? Tell me the vertex. Negative 3, comma, negative 5. Negative 3, negative 5 is your vertex. Are you guys all okay with that? I know it's getting loud out there, but can you find me that vertex? So let's say I wanted you to tell me, does this have answers? These guys are loud. Does this have solutions as low as negative 7? You'd say, well, no, the graph doesn't get as low as negative 7. Right? And I know that purely based on just that number right there. That makes sense? But let's say I wanted to know the y-intercept. Well, if I could convert this into standard form, I could find a y-intercept. To do that, I would write it like this, x plus 3 next to another x plus 3. Because isn't that what a squared sign means, is that there's 2 of them? Then when you write 2 of them next to each other, this is like grade 9 foiling. This foils to x squared plus 6x plus 9. it still has to get doubled. And then subtract 5. You guys follow what I did there? I'm just foiling out the squaredy part. Then I'm going to times it by 2 to give me 2x squared plus 12x plus 18. But then afterwards I have to minus 5. So my final answer is 2x squared plus 12x plus 13. There. Now it's in standard form. When you guys learned back in grade 9 how to distribute and do all this sort of stuff, I'm not really sure that you were told the end game as to like why it was useful, but maybe now in grade 11 you can see distributing is useful because now that it's in standard form, I know my y-intercept. My y-intercept is 13. Does that make sense? Okay, let's talk about this next one right here. How would you describe this format of a quadratic? What form is it currently in? Yeah, it's in a factored form, right? What is factoring good for? Your roots, your x-intercepts. I already know what my x-intercepts are. My x-intercepts are at 1 and negative 2. Because this 1 and this negative 2 is what makes it equal to 0. So that's a great use for standard form, or for factored form. But again, if I wanted to have, say, a y-intercept and not have to graph it, well, then just FOIL it out. So let me FOIL it. You'd have negative 2, and then you'd have x squared minus x plus 2x minus 2 if you FOIL this guy. X squared minus x plus 2x minus 2. Yeah. You could then combine the middle terms and get this. And then if I'm not going too fast here, then when you're done, just times it all by minus 2. So there. There's your equation in standard form. Is there any huge benefit to being in standard form? Well, there's only one benefit. I know my y-intercept, which is 4. Okay. I didn't lose anybody so far. I'm just foiling stuff. Okay. Well, another. Okay. So standard form tells you y-intercepts. Now, factoring is a grade 10 skill we worked on. And again, at the time, I don't know that we were really able to explain to you why factoring is useful. But now that you've seen how it all fits together, factoring is useful because it can tell you where your x-intercepts are, right? Without using a graphing calculator. Right? If I can factor this into x plus... Actually, this doesn't factor, does it? Make that a plus sign. X plus 7, x plus 3. There. If I tweak it slightly so it does factor, now I know my x-intercepts are at minus 7 and minus 3. That's why we would care. To save time, you guys know how to factor, right? I don't need to spend the time on that. So the whole point behind this slide here is that if you can get it into factored form, then you know your intercepts. So finally to the point of my lesson then. Let's get this into vertex form. Let's use the one with the plus sign though. Do I know the y-intercept of this graph? It's 21. Do I know the x-intercepts of this graph? I just did it on the previous slide. I think they were minus 3 and minus 7. But do I know where the vertex is? Well, not yet. So what I'd like to do here is I want to show you how to get this into vertex form. And experience has taught me as a teacher, the best way for me to do this, put your pencils down. Okay. Watch me do it once. I will erase it all, and then let's write it down. Because there's a lot of steps to this. Okay. When we get it into vertex form, here's what we're hoping for. When we're done, we want to have a leading coefficient. We want to have something in brackets that gets squared. And then when we're done, we want to have a number sitting at the end. That's what our goal is. Okay. So here's your first step. When I write this equation here, the first thing I got to do is I got to figure out, do I need a leading coefficient sitting out front? Well, I shouldn't say do I need one. What is the leading coefficient out front? And I'd say, well, what's the leading coefficient on this graph here? 1. So in a way, what I'm going to do is, it's silly, but I'm going to factor out 1. And it's going to leave me with x squared plus 10x. But I'm actually not going to factor out this 21. I'm going to leave a gap, and I'm going to put 21 way over here, which at first seems weird. You're like, why are you not factoring this number out of the last one? But the whole goal of this is to get what's called a perfect square trinomial. And as a brief aside, I want to show you a perfect squared trinomial. If I gave you x squared plus 6x plus 9, this goes to x plus 3 and x plus 3, which means it can be written twice as though it's squared. Let me show you another one. If I had x squared plus 4x plus 4, it can be written as x plus 2, which means I have two of them. Does that make sense to how these guys right here are perfect square trinomials? Okay, let's focus right here. Right here, I'm going to write a number. And I need it to be the right number so this becomes a perfect square trinomial. The number is going to be 25. Here's the reason why. When I factor this, eventually, when I factor it, I'm going to get x plus 5, x plus 5. And I know this because this 5 times this 5 will give me 25, but this 5 plus this 5 will give me 10. So what I'm trying to do is I'm trying to make it so that this guy right here is a perfect square trinomial. Here's the problem. This was supposed to have a constant term that added up to 21. I still have this 21 sitting over here, but now I've randomly added 25. It's not fair for me just to randomly add 25 in the middle of the equation, but I have a great solution for it. There. I've added 25 right here, right? But over here, I'm going to subtract 25. Isn't that like effectively equal? Right? Right here, I have put an extra 25, pardon me, that didn't belong there. Over here, I'm going to subtract 25 to then make up for it. Because of that, now I can write this thing right here as a perfect square trinomial. I've already written it here. It's x plus 5, which can now be written as x plus 5 squared. We're almost there. The only other things we're missing for a true vertex form is I need my coefficient in front, which we already knew is 1, and I need to know what number goes out back. Well, originally the number was 21, but now that I had to put this extra 25 right here to compensate for it, the number that's going to go out back is going to be minus 4, because minus 24 plus 21 gives you minus 4. And now we have something written in vertex form. Now I know what my vertex is. My vertex is at -5 and -4. Now let's prove it to you. Let's confirm that with a calculator just to make sure I'm not lying to you. Not that you'd expect me to, I'm sure, but come on. Why aren't you working? That's not good. There we go. Okay, so what was our equation? It was x squared plus 10x plus 21. I'm going to graph it. We believe the vertex should be at -5 and -4. So far, that's in the right quadrant at least, right? To confirm it on our graphing calculator, I would use minimum. There you go. -5 and -4. So this would lead to a question from some kids. They're like, well, why don't we just use the graphing calculator the whole time? Guys, guess what the graphing calculator is doing? This, right? When your graphing calculator has been given a maximum or minimum program, it literally has a computer algorithm written in to try to calculate this sort of information. So like that's what your calculator is doing anyways. Does that make sense? Someone has to be the person to program the calculator. Because I find a lot of kids, they'll be like, well, why don't I just use technology? And I go, but doesn't there have to be a computer engineer who understands how the software works so that when it breaks down, they know what's happening? Right? So anyways, why don't I try this one again now? And you guys can write down the steps now. I'll try to go a little bit slower here. So write this one down with me here. First thing you want to do, if there's a leading coefficient, we need to factor it out. In this example right here, there really wasn't a leading coefficient except for the number 1. So I'm going to factor out a 1, and I'm going to leave x squared plus 10x. And I'm going to leave a little gap right here, and I'm going to throw the minus 21 way the heck over on the right-hand side. This is still the exact same equation. I haven't changed anything. Second step, I would eventually like to write this thing right here as the product of two different things so that when I'm done, it can be the same thing squared. Which means I need to put a number here. And this is the hardest part for most kids. You have to figure out, well, what number should this be? And so I can give you a couple of general rules. What you're looking for is a number so that when the number adds, it gives to 10. But when the number squareds, it gives to this number right here. And so I kind of told you it was 25. One way you can figure this out every time is take this number right here, cut it in half. What we'd like it to be is x plus 5, x plus 5. So whatever this number here is in half goes here. But the number that goes here then is 5 times 5, which is 25. Now you might say, well, Chris, why do I bother writing this 25 right here? I know it's going to go to x plus 5, x plus 5. But the reason why you need this 25 right here is that we can't just randomly add 25 without subtracting 25. I screwed up here. This was a plus 21, wasn't it? Okay, well, we're nearly there. This thing right here was factored into two pieces which were identical, so we just squared them. Our leading coefficient is 1. All we have left to do is add our outside numbers. Minus 25 and minus 24 gives there. There, now we're in vertex form. The single hardest part of this battle is knowing what number to put right here. Once you get the hang of it, it's actually not that bad. Okay, one try through. How'd you guys feel? Okay, let's try another one. I've got some steps here. Okay, if you're the kind of person who wants to literally write it out step by step what to do, you can read these. But I'm going to move past if it's okay. I'm just going to try another example because I think that's the best way to learn something like this. So let's try another one. Let's put this in vertex form. So step 1. We need to try to write this in such a way that when we're done, we have a leading coefficient. And then we need something to eventually break up into two brackets so that it can be squared. So I'm kind of filling out my basic framework here. We're going to need a coefficient. So I'm going to start writing out here. This is going to be x squared minus 4x. What's the leading coefficient need to be still, though? 1. Does that make sense why it's 1, by the way? Way the heck over here, I'm going to throw minus 11. Okay, I kind of have the rough framework in place right now. The biggest struggle is, what the heck goes right here? It's actually 4. So here's how you can kind of figure that out. This x minus 4 right here is going to eventually give me x minus 2 and x minus 2. The reason why is that minus 4 is really made up of a minus 2 and a minus 2, right? Because those are the two numbers that add to give minus 4. However, the number that needs to go here then is whatever happens when you get minus 2 times by minus 2, which is actually plus 4. As a side note, this number right here, guys, always positive. It has to be. This number right here that you add in these brackets is always positive. That makes sense? Because even if these two things right here are negative, when you distribute that last term, it's always a positive. So I already know this is going to be x minus 2 squared when we're done. The problem I'm coming across now is, well, what is going to be my y value of this? And it's not minus 11 anymore. Because I added 4 right here, I have to subtract 4 right here. And because of subtracting 4 right there, it means my other value is minus 15. That makes sense? How do you get into standard form? FOIL stuff, basically, right? If you want to go into standard form, FOIL this. How do you go into factored form? Factor. Right? And like literally, these are the skills we've been teaching you in grade 9 and grade 10. If you guys remember, you first learned how to distribute stuff in grade 9. You learned how to factor stuff in grade 10. This is the culmination of those 3 skills. What if I give you something in standard form? Could you throw it into a vertex form? Again, not that your calculator can't do this for you, but we need to be able to do this ourselves. Okay, this one's slightly more challenging. It's not that much worse, but there's a twist that we didn't have the last time. How'd it go? Oh, well done. What's the twist on this one that we didn't have last time? There's a leading coefficient, right? So we don't change a ton, but we do have to factor out the leading coefficient. It's going to go 2 bracket x squared plus 4x. I'm only going to factor the 2, though, out of the first 2 terms. You could try to factor out of the last term. I don't recommend it. It just makes it tougher. Only factor out of the first 2. And throw that minus 3 way the heck over there. Well, the only changes now are that we're still looking for this to break up into 2 pieces. So when we're done, that can be squared. Okay, so let's work down here first. What are the 2 numbers that add to give 4 that are the same number both times? 2, right? Because 2 plus 2 gives you 4. Okay. When you FOIL this, when you do this 2x times this 2x right here, or when you add this 2x and this 2x right here, it'll give you that 4x, right? But I can't just go right to here because I'm still missing something. I need to know what number goes there. So if I were to have FOILed it, this would be a plus 4. Here's the part that if kids get something wrong, this is the part they miss. This number right here is actually minus 8. Okay, someone explain to me why I put a minus 8 there rather than a minus 4. Yeah, I didn't actually put 4 here. I put 2 times 4 here. 9 times out of 10, when the leading coefficient is 1, we don't have to worry about it. But on this rare instance where there is a 2 sitting out front, this 2 times this 4 right here means we actually added 8, so we have to subtract 8. So, as long as you don't mess that part up, now it's not bad. Now it's in vertex form. I know that the vertex is at -2, -11. But, guys, okay. But you do have to remember that this 2 times by this 4 to give that minus 8 right there. Did everybody catch that? Well, here's the last type of example I could give you. What if it doesn't give you a nice number? What if it gives you something that's like 3s and 7s, things that don't divide by each other? In theory, you actually can still do this. Okay. You know how sometimes the quadratic formula, when you finish solving the quadratic formula, it gives you a really ugly decimal number? Well, that could still happen right here when you're trying to solve for the vertex. What guarantee is that the vertex ends up being at whole numbers? Right, let me graph this one first. What guarantee is there that your vertex ends up being at like 3, 7? Well, there isn't any. It could be at something really gross, some sort of almost irrational number. If I find the maximum here, okay, the vertex is at 1.166666664 and 3.0833333. Right? They're not at like nice even numbers, right? But can we still do it? Yeah, it just means we need to work with fractions. So let me walk you through one of these ones here where it actually is going to involve a fraction. First question, what's your leading coefficient going to be? -3? Okay, so factor out a -3. Well, when you factor the -3 out of the first term, it gives you x squared. But when you factor it out of the 7, this is where you're not going to like this, it's going to give you -7/3. Think that through for a second here. If you took -3 and you FOILed it back into -7/3, wouldn't this -3 and this 3 and the minus cancel, leaving you with 7? But what sucks is that this term now right here is not like a whole number, that's all. You can still work with it, it kind of stinks, that's all. Okay, we now need to break this up into two brackets right here, such that when we're done, it can be squared. And again, kids, this is usually the step they get stumped on. They go, well, what number should go here? Well, what you're really looking for is half of this. What is half of 7 over 3? I don't know. Does someone have the clipboard in the other one there? Sorry, I don't actually know where it is, Stephanie. I can't actually be helped right now. The answer to this, sorry, is 7 over 6. It's 7 over 6. If I can show you why, if you take 7 over 6 and you add 7 over 6, you would get 14 over 6, which would then reduce right back down to 7 over 3. So although some kids, they get freaked out by fractions, it's actually really easy. All you do is you take the bottom number right here and you double it, which is really what happens when you cut something in half. Does that make sense? So if this was 7 over 4, it would then be 7 over 8. If it was 7 over 5, it would be 7 over 10. But because it's 7 over 3, it's now 7 over 6. That's actually not that bad. And using that same logic, I should be able to now tell you what this number right here is, because 7 times 7 will give me 49, and 6 times 6 will give me 36. I'm most of the way done. I now know the inside coordinate. The inside coordinate was, since this was 7 over 3, it's 7 over 6. That's the easier one. The crappier part here, though, is, you know how I added a number right here? I now have to put that same number on the outside, but I also have to deal with timesing by -3. Did you finish? Sweet, just throw it in the bin there, would you? So here's how I write this myself. Because I had -3 times by 49 over 36, I'm going to add 3 times by 49 over 36. This is kind of like how I write it. Okay. I'm going to add 3 times 49 over 36 because I'm doing this guy times this guy here. Except because there was a minus right here, I need to actually add more. That's all. One more thought here. These two numbers are eventually going to get added, which is kind of annoying. So why don't I make one quick fix? Why don't I give them common denominators and just call this 36 over 36? So when I'm done, I'm just going to grab my calculator to help out here. My denominator is going to be over 36, and what I'm going to need is 3 times 49, and then I'm going to need to minus 36. You see how I pulled that off? I times the 3 by the 49, then I minus the 36, and that's how many 36ths I have left. Which I'm going to check my work now. Hopefully this is the right answer. Okay, let's check my work. I said earlier that my vertex was at I said it was at 1.16666 and 3.0833. Let me check and see if those numbers match. 7 over 6 is 1.6666 repeating. And 111 over 36, here's hoping I didn't screw up, is that number right there. Does that make sense? So this is what your calculator is doing. When you ask your calculator to find a max or a min, this is what it's doing. And I think this is why you can give it a little bit of leeway, because sometimes it's rounding very oddly. Like at some point, you know how sometimes it gives you like 2.999999, and you're like, why didn't you just call it 3? Well, because it's doing this. It's completing the square. even though it may not necessarily need to, that's what it's being asked to do. So, okay, good news scenario here. Guys, I'm not going to ask you to do this one very often because the fraction one is very challenging. But you should be able to take a good stab at it. The hardest parts, I think there's two hardest parts to the fraction. The hardest part here is that once you get this guy right here, the number that goes right here and right here, all you have to do is take the bottom number and double it. So if it was 7 over 3, it's 7 over 6. If this was 7 over 5, that's now a 10. Does that make sense? That's the first hardest part. The second hardest part is like how to deal with the number that's on the outside. You have to have some pretty good skills with using like common denominators. But again, can you guys see why I put the units in the way I did? I made sure that our fraction unit was done at the beginning of the year, so you have a little more familiarity with working with fractions, because I knew this was coming later. Let's say you want to practice this, because you recognize it's really hard. I got good news for you. It's really easy just to make up your own random equation. Right? We could just try one more just for practice. Let's try, like, say, negative 2x squared plus, give me a number, 4x, give me a number, plus 7. You can just make up your own example, right? Because really, you don't need me to make you an example. Just write some numbers out. So, factor out negative 2. It leaves you with x squared plus, actually not plus, it'd be x squared minus 2x. Way the heck over here, I'm going to throw the 7. All right, now start filling out the rest of your framework. We want to turn this into something so that we have the same thing written twice. This guy right here, you just need half of it. What's negative 2 cut in half? Negative 1. Which means that when you FOIL this last term out here, this will be a plus 1. Okay. Last step here then. I randomly put a plus 1 right here though, which means that over here I need to account for that. But I didn't actually put plus 1 here. I actually put minus 2. So this stumps a lot of kids here. I actually put minus 2 inside the brackets, so I better add 2 on the outside of the brackets. There, now we're in vertex form. Does that logic make sense? I feel like I lost you there. I didn't put a plus 1 here. I actually put negative 2 times 1, so I actually put a negative 2 there. So how do you counter putting a negative 2 in this location here? Put a plus 2 over there instead. Okay, I have one last slide, right? This is the last one. Okay, so let me come back to my original point of our lesson. I don't know if you guys noticed the way I structure my lessons. I always try to really, really force the issue as to what I'm trying to do. Then I'll teach you some stuff, but I want to come back again. Why do we care about vertex form? Vertex form lets us know really easily if we can solve something, right? Let's say that I gave you this equation now. I'm going to give you this equation here. Negative 3x squared minus 18x plus 10. And I want to see whether I can solve it and see whether it's equal to 3. Do you know right now whether there will be answers? Is it blatantly obvious where it's like, this won't work? Well, not in standard form. You know what I mean? But if it was in vertex form, that might help. So here's what I'd like to do. I'd like to first solve this by using the quadratic formula, because that's actually what I showed you guys how to do first. If you do want to solve it, you could use the quadratic formula by doing this. Minus 3 from both sides. You could go 3x squared minus 18x plus 7 equals 0. And then you could use the quadratic formula. I'm just going to start the basics of it. It would give you 18 plus or minus 18 squared minus 4 minus 3, 7, all over 2 times minus 3. Actually, you know what? I came this far. I may as well finish this. Okay, let's see. Minus 18, square it. Minus 4, minus 3, and 7. Okay, I got 408. Somebody else just check my math. Make sure you guys get the same things as me. Is this solvable? It looks like it is. Is it going to give us nice round even numbers like 1 and 2 and stuff like that, or decimal? Yeah, it's going to give you an irrational number, but at least we know it's solvable, right? What I'd like to show you now, though, is we can do the same thing by completing the square. And this is what your calculator has been taught to do through some computer programming. So if it's okay, I'd like to do now part B. This is really my goal. We can also do this by completing the square. And then we'll call her a day. So just a new page here. Okay, it was negative 3x squared minus 18x plus 10. So I'd like to try completing the square on this guy first. So step 1, factor out any leading coefficients that would be necessary. Our leading coefficient today should be negative 3. When you factor that, it'll give you x squared plus 6x. And then way the heck over here, we just need our plus 10. Okay, next step. I like to start filling out the framework underneath it. We want to make this a perfect square trinomial so that when we're done, it can be squared. Once you get the habit of it in terms of what's going to happen, all you need is half of this number. So half of 6 is 3. So I'm just kind of filling in the stuff around it. It should be on wherever the clipboard is. I just don't know where the clipboard is, I'm sorry. Oh. Okay. That's fine. Oh, it's in the other. Sorry, just throw it in there. Hey, nice. I have half of it made. It's sitting on my table here. You can take what I've got here. No, I've got some stuff that's just slightly tweaked. I've got up to number 5 done. I'll have it finished in a few minutes, though. Okay. Do you want to just wait? Okay. Behind. Okay, where were we here? Is everybody okay with this framework so far? What number goes here, then? Okay. Which means that we need to then subtract, well, because it's minus 3 right here, we need 27 more. That's maybe the hardest piece of logic some kids come across, is that we didn't add 9. 3 times minus 9 made that minus 27, so we need to add 27, which means that this is 37 there. Now we're in vertex form. Roughly, this is going to be a graph that's going to have a vertex at 3, negative 3, and 37, and it's going to go upside down. The negative means it's upside down. This is negative 3, 37. So there's my quadratic. And my question earlier was, when will this equal 3? Will it equal 3? Yeah, totally. It'll equal 3 twice over there. But here's a really easy way to solve for that value. How can you get x by itself? Subtract 37 from both sides. It'll give you minus 3 equals x plus 3 squared. And then 3 minus 37 gives you minus 34. Okay, then to get x by itself after that, we need to get rid of this leading coefficient. So I'll divide by minus 3. So now x plus 3 squared is whatever 34 over 3 is. You know how in the first example I did today at the beginning of the lesson, at this step here, I had encountered an error because I was trying to square root a negative number? Do I have an error this time, though? No. Okay, so let's square root both sides. So now I'm going to square root 34 over 3. And then can I just do this all in one step? You'd also have to subtract 3 from both sides. There's where x is. Now, technically, you actually have to do the plus or minus version of this, but I'd like to show you 3 ways now that I can show you the exact same answers. And then we'll call her a day. If I were to square root 34, divide by 3, and then subtract 3, I believe this is one of my answers. On the previous page, I also believed that this was an answer. So I'm going to try this one as well. 18 plus the square root of 408 divided by -6. Actually, I'm going to use the negative version first. Same answer. And there's a third way I could solve this as well. I could just go to my graphing calculator and see where this quadratic right here eventually equals 3. And when I graph it, clearly there's two answers right here. Let's go second calculate the intersect. Right about there. I also get that 0.3665 number. So now there's actually 3 ways you can solve something. Method 1, type it in your graphing calculator, find where it crosses. It's a great method. Method 2, use the quadratic formula. Method 3, we don't use this a lot, but it's very possible to complete the square through the process we just did here, then make it equal to that 3, and all you've got to do is just get x by itself by subtracting this number, dividing this number, square rooting both sides, and then whatever is left inside the brackets, moving that as well. So there's 3 different ways you can solve. That makes sense? Okay. I'll call it a day there then. So this lesson here, a lot of teachers actually teach it in the algebra unit, but I feel like that wouldn't have been the right time to show you because I don't think you would have fully understood what the point of it was. I'm hoping now that we've done rationals in our algebra unit and you know better purposes of graphs, now that I show you how to get something in a vertex form, my hope is you'll get why we would even care. So, okay, unless you guys have any questions. That was my last slide, I think, right? Yeah. Okay, I'll stop the lesson.